Class has started, and I need to go through some old flashcards that I found. I want to find the flashcards for Organic Chemistry 1. I'm taking Organic Chemistry 2 right now, and I could use a review because I didn't take Organic Chemistry 1 last semester. I took it over the summer, so it's been a few months since I looked at this stuff. So I'd like to find those flashcards and see what I can review. Now this stack here, this isn't just chemistry flashcards. This is all my flashcards from last year. So it's not organized. Like, I'm gonna have to go through them. For example, looks like this is physics. I have concave and convex lenses. This is biochemistry. Glutamate, aspartate, oops, how did I do that? I did it like that. Aspartate, asparagine, histidine, lysine, glutamine, asparagine, cysteine. It's a little tricky to pick up. Threonine, serine, tryptophan, tyrosine, phenylalanine, methionine, isoleucine, leucine, valine, proline, alanine, glycine. All right, very good. Biochemistry, I'm going to set over here. I'll make a little physics pile here if I find any others. And now, oh, this looks promising. This looks like it could be Organic Chemistry 1 because it says Elimination reaction. Little fuzz on it. Oh yeah, these are, oh, perfect. These are definitely organic. This is what I need to study. What's this? This looks like Calc 2. So much fuzz. Chemical identities. Reduction formulas. Are these all calc? Looks like a whole lot of calculus. Okay. I think I'm finished with calculus for my whole life. I'll set those over there. I know I'm taking biochemistry 2 right now, so I'll probably need these amino acids this semester. These lenses, I'll probably need them again, but what? I don't even remember. Oh, yeah. Physics. I'll set it over here. And Calc can go over there. Now, these organic flashcards. I don't remember much of anything here. I'm just going to look through them, and I'll talk quietly about them and try and piece together a memory or something. So this says elimination reaction. Okay. Ethanol with an acid catalyst goes to ethanol. ethylene plus H2O. I'm going to have to go back further than this. Addition reaction. These look like some definitions. Some instructions. Oh. Maybe the answer is elimination reaction and I'm supposed to determine what it was from this drawing. I think that's the problem. I think I just have them upside down. So, I guess I would ask myself, from ethylene, which is an alkene because it has a double bond, if I added hydrogen bromine, where would that add on? Oh, and it would go to a bromoethylene, which is an alkyl halide. So that's an addition reaction. I don't know that from memory. I know it because I just saw it. See? Okay. What's the difference between deposition, condensation, and sublimation? Okay, I know this. Deposition goes from, I'm going to guess, a gas to a solid. Condensation goes from a gas to a liquid. And sublimation, I'm going to guess, goes from a solid to a gas. Let's see. Deposition, gas to solid. Condensation, gas to liquid. Sublimation, solid to gas. Is that what I said? I think so. Okay. Anti-Periplanar. What does that mean? Anti-Periplanar. Let's look. Anti-Periplanar is when the stereochemical relationship in which, is the stereochemical relationship in which two bonds on adjacent carbons lie in the same plane at an angle of 180. Okay, two bonds on adjacent carbons lie in the same plane at an angle of 180. Okay. An SN2 reaction. Okay, that's a substitution reaction with two parts. Let's see what it says on the back. To do a substitution reaction, you draw the low priority group in the back and the leaving group in the plane of the paper. Okay. There's a backside attack, show the intermediate, and show the product with inversion. I need a sip of my coffee. That looks pretty good, huh? E2. It's going to be a two-step elimination reaction. Okay, show the anti-periplanar conformers in a Newman projection. Show multiple products. Okay, anti-periplanar, we just learned, is when two bonds on adjacent carbons are in the same plane at 180 degrees. Is that right? Stereochemical relationship in which two bonds on adjacent carbons lie in the same plane at an angle of 180 degrees. Okay, we're making some progress. SN2. It's a substitution reaction with one step. How do we do that? Show the leaving group leaving behind a carbocation with all atoms in the plane of the paper. Show the two sides that the nucleophile can attack from. Show two products. Okay. Show the leaving group leaving behind a carbocation with all atoms in the plane of the paper. Show the two sides that the nucleophile can attack from. Show two products. Okay. An E1 reaction, that's elimination reaction with one step. I can see through this paper a little that there's like a 2. I wonder what I said. Show the leaving group leaving a planar carbocation. So that's different from the... No, I guess not. Show the leaving group leaving behind a planar carbocation. Show the two products that give the most highly substituted double bonds. Show a leaving group leaving a planar carbocation. Okay, show the two products that give the most highly substituted double bonds. E1CB. Let's see. Form a carbanion. Show the leaving group leave. The double bond to oxygen may be what did I write there? The double bond to oxygen, I'm going to guess it says moves to between the carbanion and the carbon that had the O as a resonance stabled anion. Product has a double bond to oxygen and a double bond between the carbon with the leaving group and the carbanion. Okay. You know, I don't do myself any favors when I write these. These are really scrawly. But I can kind of make it out. So let's just say it wouldn't be as fun if it was easy. All right, what's an alkene? An alkene is a hydrocarbon that contains a carbon-carbon triple bond. An alkene is alkene. Alkene? Oh no, I can't remember how to say it. Let me look it up. One moment, I'm going to the Google. A-L-K-Y-N-E. Pronunciation. I'm learning here. It'll be just a second. Okay. How do you pronounce I'm going to say alkyne. Yeah, okay. I'm sorry that was confusing. Okay, so let me start fresh, calling this an alkyne and not an alkene. Alkyne is a carbon-carbon triple bonded hydrocarbon, right? Oops. A hydrocarbon that contains a carbon-carbon triple bond. All right, resonance. Okay, that's when the structure stabilizes an ion, I think. Okay, effect. The donation. Okay, resonance effect is the donation or withdrawal of electrons through orbital overlap with neighboring pi bonds. Example: oxygen and nitrogen donate an electron to the aromatic ring by overlap. A resonance hybrid. A molecule like benzene that can't can't be represented adequately by one calculae structure and must be considered an average of two or more forms. They differ only in position of electrons. Yeah, okay, I remember that. Zaitsev's rule. I have to write a report on this by Tuesday. It's a lab report. Okay, Zaitsev's rule says that the major product is usually the most substituted, but it depends on stereochemistry. Is that right? Okay, in E2 elimination reactions, that's elimination with two steps. E2 elimination reactions normally yield the more highly substituted alkene as a major product. Okay, yeah. Retention. Qu'est-ce que c'est? Retention. When the replacement ligand occupies the same site, same site on the chiral center as the replaced ligand. Retention. Oh, gotcha. So like not inversion? When the replacement ligand occupies the same site on the chiral center as the replaced ligand. I don't know. Carbocation. A substance that contains a trivalent, positively charged carbon atom having 6 electrons in its outer shell. Typically formed by loss of electrons. Say what? Positively charged carbon atom having 6 electrons in its outer shell. Positively charged carbon atom having 6 electrons in its outer shell. Okay. Well, carbon, cation, positive. You know how I remember that. An anion is negative because it's negative to have ants in your house. But a cation is positive because it's positive to have cats in your house. Equals rule. Monocyclic conjugated molecules having 4n plus 2. Conjugated molecules having 4n plus 2 pi electrons. N is the integer. Oh, that monocyclic conjugated molecules having 4n plus 2 pi electrons are aromatic. Gotcha. Second order kinetics. A reaction whose rate limiting step is bimolecular and whose kinetics are therefore dependent on the concentration of two reactants. I knew that one. Conjugated. Ooh, got some scribbles. A series of overlapping p orbitals, usually in alternating single and multiple bonds. Example, 1,3-butadiene is a diene. Is a conjugated diene, I think is what I was trying to put in there. 3-butadiene is a conjugated enone. Benzene is a cyclic conjugated triene. So I guess the answer was conjugated, and I should put this like that. I wonder if these all go. Yeah, these seem to go like that. Like fill in the blank cards. A substance that contains a trivalent, negatively charged carbon atom. That's a carbanion. No, carbocation. Wait, no, carbanion. I'm going to say carbanion. Are 3sp hybridized and have 8 electrons in the outer shell of the negatively charged atom. Nailed it. Oops, put it backwards. I need another sip of coffee, please. reaction that takes place in a single step without intermediates. Dice-alder cycloaddition reaction is it takes place in a single step without intermediates. It's a 1, so I'm going to say first order process. Concerted, like in concert. Let me try that again. A reaction that takes place in a single step without intermediates. Example, dice-alder cycloaddition reaction is a concerted process. A cyclic molecule whose ring contains more than one kind of atom. For example, pyridine is a blank that contains 5 carbon atoms and 1 nitrogen atom in its ring. Let's substitute it. Pyridine, cyclic ring. What would it call? A heterocycle. Cool. When electron density is spread out over a conjugated pi electron system. Example, allylic cations and allylic anions are delocalized because their charges are spread out over the entire pi electron system. Aromatic compounds have 4 and 2 plus 2 pi electrons. That's Huckel's rule, I remember that. Blank over their rings. Okay, resonating? Spread out. What's the word for that? Delocalized. Okay. Stereospecific. Only a single stereoisomer is produced in a given reaction rather than a mixture. Anti-aromatic. Turn that back over. Planar conjugated molecule with 4 pi electrons. Delocalization of the pi electrons leads to an increase in energy. Planar conjugated molecule with 4 pi electrons. Delocalization. Delocalization, we just learned that one. Spread out charges of the pi electrons leads to an increase in energy. Anti-aromatic. Increase in energy. All right. First order kinetics. I think that's when only one substance determines the rate. A reaction whose rate-limiting step is unimolecular and whose kinetics, therefore, depend on the concentration of only one reactant. Rate-limiting step. It's the one that goes the slowest. The slowest step in a multi-step reaction system acts as a bottleneck in multi-step reactions. Inversion. I think that's when it's not retention. When the molecule that was in the front goes to the back or something. Replacement of a ligand on a chiral center in a reactant at the site opposite where the replaced ligand was. Ligand. Okay. Oh goodness. The addition of water to alkenes. Oxymercuration. Laboratory scale. Hydration of an alkene. Use mercuric acetate and THF followed by NaBH4. Markovnikov orientation via mercurium ion. Oh man, oh man, oh man. Look at that. Okay. That is a lot. So the OH goes on the more substituted carbon, for sure. Oh electrophilic addition for preparations. Successful with HCl, HI, and HBr. Those guys are enablers. HI is generated from Ki over H3PO4. Orientation in Markovnikovs. Hydrogen attaches to the carbon with the most hydrogens. Oh, so this was an anti-Markovnikov. Or no, Markovnikov. Oh, yeah. So the hydrogen attaches with the carbon with the most hydrogens. So the least substituted. And the other one goes to the more alcohols substituted. The more highly substituted carbocation forms as intermediate because a tertiary cation is more stable than primary. Hydrogen did go on to the carbon with the more hydrogens. And then the chlorine went on to the other carbon. That's Markovnikov. So, I'm gonna guess that, yep, okay. I get it. What is that word? Addition of hypohalous acids to alkenes. Halohydrin formation. Addition of OH to an alkene to give 1,2-halo alcohol is called halohydration. Reagent is the dihalogen. Bromine 2, chlorine 2, Br2, Cl2, and H2O. Okay. So the OH goes on one carbon and the halide goes on the other. The bromine goes on the more substituted carbon. The OH goes on the carbon with the more hydrogens. Addition of bromine and chlorine to alkynes. Got it that time. Initial addition gives a transintermediate product with excess reagent is tetrahalide. Okay. Addition of bromine and chlorine to alkenes, 3 bonds. Alkynes, 3 bonds. Addition gives transintermediate. Okay. 3 bonds. Add a protein. A bromine gives a transintermediate. And then product with excess reagent is a tetrahalide. Tetrahalide, huh? Addition of halogens to alkenes, bromine and chlorine. Add 2 alkenes to give 1,2-dihalides. Chlorine 2 reacts as chlorine plus, chlorine minus. Bromine is similar. F2O. reactive I2 does not add. Okay. You have ethylene plus chlorine 2 adds on that way. Okay. Preparation of alkynes. Elimination reaction of dihalides. Oh my goodness. All right. So we're making an alkyne by doing what? That chlorine goes away. And that hydrogen goes away, I guess, to HCl. I guess so. Huh. Preparation of alkynes. Elimination reaction of dihalides. Treatment of a 1,2-dihalidoalkane with KOH or NaOH produces a twofold elimination of that. Dihalides are available from addition of bromine or chlorine to alkene. Intermediate is a vinyl halide. Okay, we have an alkene plus a bromine makes an alkane. Because you add the bromines and break that center bond. Okay, and then adding KOH. Takes off the bromines. And the hydrogens? No, the hydrogens are still there. Takes off the bromines. I don't know. Wow. This is going to be a lot of work to get ready for class. Because I have forgotten a lot. Elimination from alcohols. Alkenes from alcohols. Okay, we have an alcohol. 2-methyl-2-butanol. To take the alcohol off. Some of them become that, which is more substituted. And some of them become that. Minor product, got it. Try substituted 1, 2, 3. Die substituted 1, 2. Alkenes made from elimination of drugs from an alkyl halide dehydrogenation using heat and KOH, elimination of hydrogen or OH from alcohol dehydration. Got it. Requires strong acids. Okay. So this happened in my experiment this week. Bromocyclohexane, added potassium, KOH. Bromine goes away and so does hydrogen to make H2O and KBr. Interesting, I getcha. What's that? Degrees of unsaturation. Saturated would be CnH2n plus 2. So the number of carbons. The hydrogens are H2 times the number of carbons plus 2. So we have 4 carbons. We need 8, 9, 10 hydrogens. And that's going to be right? Carbon has 1, 2, 3, 1, 2, 4, 5, 6, 7, 8, 9, 10. Yeah, that's right. Each ring or multiple bond replaces 2 hydrogen. Got it. 1 degree of unsaturation. Double bond or a ring. 2 degrees of unsaturation is a triple bond. Consider fluorine, chlorine, bromine, iodine as hydrogen. Okay? Ignore oxygen. Okay? And subtract 1 hydrogen for every nitrogen. I guess this is the formula. 2 carbons plus 2. Okay, so 2 times the number of carbons plus 2 plus however many nitrogens there are minus the halides. Minus what? Minus the hydrogen divided by 2 degrees of unsaturation. I need to think about that a little bit more. A successful synthesis combines a series of proposed steps to go from a defined set of reactants to a specified product. Acetylene ions can react as blank as well as blank. What can they react as? Nucleophiles and bases. sp hybridization at carbon holds blank relatively close to the positive nucleus. Electrons. Negative charge from electrons, says me. Strong oxidizing reagents, O3 or KMnO4, cleave internal alkynes, producing 2 alkenes. No, carboxylic acids. Strong oxidizing reagents cleave internal alkenes, producing 2 carboxylic acids. Addition of H2 over a metal catalyst converts alkynes to alkanes. Because the addition of the first equivalent H2 produces an blank. I'm going to guess alkene, which is more blank than alkyne. So the blank is not observed. Complete reduction. Alkene, reactive alkene. Addition of H2 over a metal catalyst, like palladium over carbon, converts alkynes to alkenes. Complete reduction? Yeah. Oops. Because the addition of the first equivalent H2 produces an alkene, which is more reactive than the alkyne, so the alkene is not observed. Secondary vinyl carbocations form less readily than, I'm going to guess it's either primary or tertiary. Primary alkyl carbocations. Secondary vinyl carbocations form less readily than primary alkyl carbocations. Organic synthesis creates molecules by design. Enols rearrange to the isometric blank by the rapid transfer of a proton from the hydroxyl to the alkene carbon. The blank form is usually so stable compared to the enol that only the blank form can be observed. Okay, so enols go to ketones, and I'm going to guess that one of these words is tautomerization. Oh no, ketone, keto. Enols rearrange to the isometric ketone by the rapid transfer of a proton from the hydroxyl to the alkene carbon. The keto form is usually so stable compared to the enol that only the ketone form can be observed. Alkynes do not react with aqueous protic acids. Wow, I never would have gotten that. Alkynes do not react with aqueous protic acids. Blank have been found in outer space. Well, honestly, I have no idea. Okay, Paulines. My handwriting is getting really nasty. I must have been getting tired when I wrote these last summer. Hydroboration oxidation gives the blank product. Okay, hydroboration oxidation. I'm going to say anti-Markovnikov, but it might be Markovnikov. Non-Markovnikov. Terminal alkenes are less substituted than, well, what are they? Okay. Terminal alkene are weak Bronsted acids. Alkenes and alkanes are much less acidic. Isometric compounds that can rapidly interconvert by the movement of a proton are called blank, and the phenomenon is called blank. Is this tautomerization? Tautomerization. What was it again? Isometric compounds that can rapidly interconvert by the movement of a proton. Mercury 2 catalyzes, well, mercury goes Markovnikov, I know that. Mercury 2 catalyzes Markovnikov-oriented addition. Some of these I am sussing out. Carbon-carbon triple bond results from blank on each carbon forming a sigma bond, and unhybridized px and py orbitals form pi bonds. What? sp orbital. Carbocation triple bonds result from sp orbitals on each carbon forming a sigma bond, and unhybridized px and py orbitals forming pi bonds. Jeez Louise. Addition reactions of alkynes are similar to those of alkenes. By definition, blank are not stable enough to exist for one vibration. Oh man, I feel like I should know these definition ones. By definition, blank are not stable enough to exist for one vibration. Transition states. Oh dang. By definition, transition states are not stable enough to exist for one vibration. Carbocations undergo structural rearrangements through blank to give more stable carbocation. Something intermediates? Nope. 1,2H and 1,2-alkyl shifts. Carbocations undergo structural rearrangement through 1,2H and 1,2-alkyl shifts to give more stable carbocations. A transition state is the blank in a reaction step. Is the highest energy point in a reaction step? Oh, I'm so proud of myself. Highest energy species in a reaction step. Carbocations are blank, and tricoordinate carbon is surrounded by only blank. Carbocations are blank, and the tricoordinate carbon is surrounded by only blank. Chiral? No. Planar. 6 electrons and 2 sp2 orbitals. Okay. Carbocations are planar. We learned that earlier. And the tricoordinate carbon is surrounded by only sp2 orbitals. 6 electrons in sp2 orbitals. 6 electrons in a carbocation in sp2 orbitals. More highly substituted carbocation forms as blank rather than less highly substituted one. Product. Intermediate. Coningold Prelog rules assign, oh man, I have no idea. The Coningold Prelog rules assign properties to the substituted groups on a carbon. Properties to the substituted groups on a carbon. Coningold Prelog rules. Sip of coffee. Blank cations and associated transition states are more stable than blank cations. Tertiary cations are associated transition states are more stable than primary cations. A reaction is blank when one product forms where two are possible. Stereospecific. Regiospecific. A reaction is regiospecific when one product forms where two are possible. Hyperconjugation is when electrons in neighboring filled orbitals, I guess, stabilize vacant antibonding. I was going to say orbitals. Oh, they are orbitals, but they're more specific than that. Hyperconjugation is when electrons in neighboring filled sigma orbitals stabilize vacant antibonding pi orbitals. Blank predicts that the transition state of an endergonic reaction step structurally resembles the product. Okay, this is probably someone's name. Let me pick you up. The Hammond postulate. I could probably remember that was some kind of Jurassic Park reference. Let's think. The Hammond postulate predicts that the transition state of an endergonic reaction step structurally resembles the product. Okay. I'll think more about how that could be a Jurassic Park reference later. The blank isomer has two similar groups on the same side of the double bond. Cis? Yeah. An occupied blank prevents rotation about the pi bond. An occupied unoccupied what? Pi orbital. Oh, I had it backwards. An occupied pi orbital prevents rotation about the sigma bond. All Entgegen compounds are blank. All Zusamen compounds are blank. Okay. All Entgegen compounds are Zusammen is same, and gegen is, I don't know. Okay. All anti-gegen compounds are higher priority on opposite sides. All zusammen are on the same side. See, same side. The opposite side. Markovnikov rule predicts that the blank is formed in blank. That the more stable carbocation intermediate is formed in electrophilic addition to alkenes. Kahn-Ingold Prelog rules. Oh, we just learned this. Oh my gosh, have I already forgotten? What am I looking at here? Okay, so free radical polymerization. Termination. The chain propagation ends when two radical chains combine, affected by reactivity and concentration. Okay. Okay, this is a free radical thing too. I'm gonna guess it's propagation because there's a free radical on both sides of the arrow. Free radical polymerization. Propagation. Radical from initiation adds to an alkene to generate alkene-derived radical, which adds to another alkene, and so on. So this is initiation because there's only a free radical on this side of the arrow. Free radical polymerization. Initiation. A bond is broken homolytically. Radicals are generated by the reaction of a molecule that readily forms radicals from a non-radical molecule. Okay, I would guess that this is termination also. Termination. This is, okay, there's one here, one there. What am I looking at? Initiation and then propagation. Propagation on both sides of the arrow. Okay, all right, you win. This is an elimination reaction. Oh, initiation. We're still on radical substitution. Initiation. Okay. Electron flow using arrow formalism. Okay, you go from the pi bond to the hydrogen, from the hydrogen to the halide, from the halide to the carbon cation that didn't get the hydrogen. Can be neutral or positively charged. What's that? An electrophilic site can be neutral or positively charged. Can be neutral or negatively charged. It's going to be a nucleophilic site, right? Yes. Delta H prime is the heat of the reaction. If it's negative, it's exothermic. If it's positive, it's endothermic. What is this? The enthalpy change. Okay, KEG is less than 1. Energy is absorbed from surroundings, and heat must be put in to make the reaction go endergonic. Enthalpy change. If negative randomness decreases, if positive randomness increases. Entropy change. I'm so sorry. Entropy change. If delta H is negative, heat is given off. Exothermic. Okay. Exergonic if less than 1. Product is favored. Or greater than 1 product is favored. Endergonic if less than 1. Reactants are favored. Delta G is negative, heat is given off. If delta G is positive, heat is required. The equilibrium constant. Steps that occur simultaneously are concerted. We're going to review. This is great. In this cleavage, both atoms leave with an electron creating free radicals. That's propagation. No, homolytic bond breakage. Two molecules combine into one. Addition. A change in electron distribution as a response to change in electronic nature of surroundings. Electron distribution as a response to a change in the electronic nature of the surroundings. Polarization. The highest energy point in a reaction step is the transition state. A reaction where delta H is positive. I'm gonna say, oh man, I should know this. We just did this. Exergonic. Endothermic. Endothermic. Endothermic is positive because heat's going in. A process wherein one molecule splits into two. Elimination. Yes. A general term for species which have electron pore sites that can form by accepting a pair of electrons. Electrophile. Yeah. Delta G prime equals negative RT ln K equivalent. Oh, I know this. This gives free energy change for like non-standard conditions. Oh no, standard conditions. Standards gives free energy change. A reaction where delta G is negative is favorable. Hexagonic reaction. Needed by reactions to reach the transition states. Activation energy. A species that lies at energy minimum between steps on a reaction. Intermediate, right? Reaction intermediate. A general term for a species which have electron-rich sites that can form a bond by donating a pair of electrons to an electron-poor sites. Nucleophile? Yeah. A reaction where two reactants exchange parts to give new products. Substitution reaction. This occurs when both bonding electrons remain with one product fragment. I'm going to guess hetero something. Heterolytic bond breakage. Polar process. A process involving symmetrical bond breaking and making homolytic. No, what the heck? Radical reaction. A process involving symmetrical bond breaking and making is radical reaction. I have a lot to learn. What am I looking at? What is this? An addition reaction? Oh, an addition reaction. Okay. This is gonna be, I guess, an elimination reaction? Yes. So the bond moved. I'm going to guess substitution. Rearrangement. Okay. So I did that wrong. Let me just, yep. Okay. Let's say substitution. Yes. This has got to be polymerization. Polymerization. Right. Polymerization. We are nearing the end zone, my friends. What are you? Hydration? Oxidation? Oxidation. Loss of hydrogen, gain of oxygen. Ozone cleaves alkenes. KMNO4 produces carboxylic acids and CO2 if hydrogens are present. Okay, we learned this earlier. KMNO4 produces carboxylic acids. CO2 if hydrogens are present. Okay. What is this? Reduction reaction. Generally, addition of H2 or loss of equivalent oxygen requires PT or PD and H2. It's a heterogeneous process. So we got PT and H2. And we're adding two hydrogens to the front. Okay. What's this? Is this elimination like an E1 reaction? Rearrangement reaction. Okay. Man, I really need to review this stuff some more. Okay. Substitution? Yes. Okay. Okay, what are you? I'm going to guess dehydration because there's a water over there. Elimination reaction. All right, elimination reaction. Okay, I won't make you go through all of these with me again, but I am going to go through them all again. Thank you so much for all your help. You've been wonderful, as always. I'll see you next time.